Now let us see. First part is completed. Now let us see the next part. We have to find out ETH. So generally which procedure we are using to find out the current flowing through the branch? We remove that particular branch. Now we have to find out current flowing through this or voltage across this load resistance. So we will remove this branch. We will remove this branch means with the help of this circuit, we will remove this branch means simple, we will disconnect the load resistance. We will disconnect the load resistance. So the circuit looks like this. The circuit looks like this. Listen, circuit looks like this. Means we have removed RL, connection parallel with R, we have removed that connections. Now this voltage is, as usual, we have given is at 15 volt. Now we have to measure the value of ETH. Now we have removed RL. So how to measure the value of ETH? Simply we will take the multimeter, we will connect across 1 ohm. So this is 1K, this is another 1K. Now let us switch on this supply. If you switch on this supply, this value will be 7.51 volt. ETH value is 7.51 volt. We got the value of ETH is equals to 7.51 or 50 volt. So first part of Thevenin's theorem, that we have to find out Thevenin's equivalent voltage, is completed. Now switch off the supply. Now which is the next step? Which is the next step for the experiment? We have to find out the value of RTH. To find out the value of RTH, we have to short circuit all the energy sources. Only single energy source is there, E1. So how to short circuit this value of E1? Simple. What we will do? We will remove this value. We will remove this value and we will connect it at this particular point. So this value is short circuited. Now what it indicates? That two resistances, they are connected in parallel. Now how to measure the parallel resistances between these two? See, we will go for the resistance. We will measure the resistance of this. Simple. This is the multimeter. I have connected the knob for ohms. Now we will connect it across the value of R2. So I will connect it one value here, another value here, and I will get this value as this value as 0.489 ohm. See, I have short circuited it. So its value will be 0.489 ohm. So no doubt one is parallel with 1. If you find out, it is 0.5 ohm. So it is 0.489. Means it is approximately 0.5 kilo ohm because its value is in 1K. Now next will be. So we have completed the second part, that we have found out the value of the RTH. Now you have to note the value of the RTH. That value of the RTH is equals to 0.489 kilo ohm. Means it is approximately 0.5K. Now for the next circuit, we have to remove all these connections. Now for the third part of this particular experiment, ETH, RTH. We have found out ETH, we have found out RTH. We know how to find out load current. IL is equals to ETH divided by RTH plus RL. So we have to make the new circuit. We have to adjust the value of voltage to ETH, which we got at 7.51 volt. We have to take the value of RTH as 0.5K. How to get 0.5K? Simple, we will connect 1K, 1K is in parallel. So first part of that, 1K, 1K is in parallel. So this is the value of 1K. This is the value of 1K. They are connected in parallel. This is the value of 1K. This is the value of 1K. See, these two values we have connected in parallel. So it gives the parallel connection, it gives the 0.5 ohm. Now let us make the circuit. Positive end. Before that one, we have to make the value of ETH. How to make the value of ETH? For that purpose, we will use the multimeter again, because we have adjusted that value earlier to 15 volt. Now we have to adjust that value to ETH is equals to 7.5 volt. So we will adjust it to 7.5 volt with the help of this knob. Switch on this kit supply. Now, see, 7.5, we will go on reducing with the help of this knob. Okay, approximately it is 7.58 or 7.57 volt. We have adjusted this voltage. Remove this, switch off the supply. Now let us make the parallel connection. This R1 they have connected in parallel, R1 and R2, because we have to get the 0.5 ohm. If you find this particular value is 0.5 ohm. Now ETH we have adjusted. So let us make this value of ETH, we have already adjusted it. This ETH is connected to RTH, one end of the RTH. Means this is the one end of the RTH. Parallel combination, ETH is going to 1. Then RTH, another end is going to RL. RTH, another end. See, this is the value of RTH. This is the first RTH. ETH is connected to RTH first end. RTH first end means this value of RTH, this is the first end of RTH. wait. RTH one end 1K, ETH, ETH, RTH 1K, cross this. So first end, this is RTH. Next will be another end of the RTH. Another end of the RTH, this end of the RTH is going to RL. So this value is RL. Next, this another value of the RL is connected to negative of ETH. Another value of RL, this value, another value of RL is connected to negative of RTH. Now what we have to do? We have to measure the voltage across that. So simple, this value, this is same end. So let us measure the voltage across this. So first end should be here, another end should be here. Let us switch off the supply. Now let us see, this value is again 5.03 volt. 5.03 volt. Earlier also we got 5.02 volt, 5.03 volt. So we get the VOP2 with the help of Thevenin's equivalent network as 5.03 volt. Without using the Thevenin's theorem, we also got this value as 5.02 volt. Hence we can say that Thevenin's theorem is verified for this particular network. Thank you.